The next presentation is about getting started with Raspberry Pi from Bernhard
Wiedemann.
Wiedemann.
Welcome everyone here. And it's not really a presentation, it's meant to be a workshop, hands-on, to do something with Raspberry Pi. And one very interesting thing which you don't have on normal computers is these GPIOs, which is the general purpose input-output pins you have on your Raspberry Pi, which look like this. And all of them are a bit different. Like you have your power pins on the top there, and you have some ground pins where the circuits will end, where the electrons go. And then you have your GPIOs, where you can either send some current or not send it, or you receive current and see, is there something or is there not something, so you can have buttons or other nice receivers. And apart from this, they have some alternative functions. For example, here GPIO 14 on the right side and 15 can be used as a serial console if you have the right adapter, and I have one here if you want to test. And for example, GPIO 4 on the left side is a clock, and this clock can tick up to 500 megahertz, which allows it to be used as a FM radio transmitter, which is a really cool hack to do. And if we have some radio receiver around here, we can try that out today as well. Okay, so that's the hardware. We have very limited resources, like one VGA connection here to the projector and one monitor there with a cable. And one serial dongle. So we can maybe have work in 3 places. So we have to form some groups and do some things. And I brought with me some extra hardware, like LEDs, which you could put on your Raspberry to play with the output on GPIOs. And I have even some traffic light and some cables, which you can use to connect, for example, 2 GPIOs to see the output of one arriving as input on another and play with this kind of stuff. Okay. Any questions so far? Wi-Fi dongles I don't have, no, sorry. Yeah, otherwise we could use that and work over SSH. But we have some cables. I have one Ethernet cable there, and we have one with internet even here. So we could work a bit with cabled network as well. And
is this a follow-up session of something, or we have started just now?
No. Okay, Raspberry Pi is a small computer which can have a case or not. Like this. And this little computer does not have an Intel CPU, but an ARM. And the ARM chip is not just a CPU, but it has it's called system on chip because it has a USB controller and a network controller included and some graphics function in this one single chip. And there's memory on board, and you can plug in your SD card in here, where you can put an openSUSE image, which I made for download. And there's also the bootloader on here. So if you do the wrong thing and overwrite your bootloader, you just take the SD card out, put it into your computer, write the image again, and then you have everything back working. So it's a really nice thing. It's very hard to break. And then you have these GPIO pins somewhere on there, on one side, where you can connect any hardware you can think of. And do a lot of cool stuff, like driving motors of your 3D printer. So you write some software to control it then. And you have an audio and USB over here, and HDMI for the graphics to connect it to some monitor or projector. So that's a Raspberry Pi. The basic. It got a lot of news attention, so I was thinking that most people coming to the Raspberry Pi workshop know what Raspberry Pi is. But, yeah, and one big advantage is it's very cheap, like 40 euros at most, and 40, yeah, and that's very little. So. They made it to give it to your kids so they can play with it, and if it breaks, it's not as bad as breaking your €1,000 computer. And yeah, with the GPIOs you can even do some things which you can't do with your computer because it's all, you don't have these pins and the functions. Okay, so, and even more people. Yeah, I'm not really sure how to organize it, or maybe we can set up some Raspberries with SSH access and use them without monitor, so we can have more groups working on something. Okay, first question, who did bring in Raspberry Pi? 1, 2, 3. What? Did? Who has one? I have one, and we have 4, 5, 6. Yeah, it's about 6, and I have this one in reserve as well. So, and we are a lot more than 6 people. Makes maybe, yeah, so maybe 5 people for one Raspberry, which, yeah. Now maybe I start by showing something which I brought. So over here I have my Raspberry, and I have an add-on board. There is an add-on board, and I just have 6 LEDs here, 2 greens, 2 yellows, and 2 reds. And this is a prototype of a traffic light. And I can, here on the back side, I have soldered each LED to its own GPIO output. And there's one 68 ohm resistor, which is good to change the voltage. Because LEDs only take 2 volt voltage, but these GPIOs output 3.3 volt output. And this 68 ohm resistor is the thing it takes to change from 3.3 to 2. There's even an LED calculation website which I used there. Yeah, which was it? This one here. And there you say, okay, I have my source voltage 3.3, and the diode can take 2 volt, and the current is milliampere 20. And then it calculates and says, okay, take 68 ohm. So that's what I did. That's the simple part. And then I soldered a bit. I'm really amateur, so it looks ugly, but it works. And I wrote a small proof of concept script to show it. So it's all done by program code. So I have not hardwired from the keyboard to the LEDs, but I have program code in between that says if I press R and enter, then it's red. So I could script it even more to say, okay, be red for 10 seconds, and be yellow for 3 seconds, and be green for 30 seconds, and then I would have a nice traffic light, maybe, if I do it right. So that's the kind of easy things you can do with a Raspberry. And yeah, question.
That one you just showed us, is it running openSUSE?
This one is running my openSUSE image, which you can download if you search for Raspberry and openSUSE. Not this one. Then you find this wiki page, and the wiki page says, here is the download URL of my image, and you download the image and use gzip and dd to put it on your SD card as a raw image. Yeah, so it's openSUSE, and it's a factory version that's not updated at the moment, but it's very close to 12.3, and so it's pretty stable most of the time. Okay. Yeah, how to continue? Any proposals? Yeah, if you have an SD card with your Raspberry that you don't mind overwriting, we can flash it.
I mean, as part of the workshop.
Yeah.
Of course, anybody can do whatever you want.
No, we want to get you going here with openSUSE on the Raspberry Pi. That's the purpose. So you can do more at home or later. Okay. So, who wants to flash his SD card for his Raspberry Pi? You? Yeah. Do you want to flash your SD card?
Yeah, I'm downloading the.
Okay, so you do it yourself? Okay. Good.
We already have the image,
I have it on my laptop, but I would have to boot it up. So, okay. Good. Who else? Or do you already have openSUSE on your SD cards? Yes? No? No response? Okay, and it's a very minimalistic image, I have to say. So there's a Super on it, so you can install more software, but there's no Yast, for example. So you have to do a Super install Yast2-network if you want Yast modules, for example. Okay, who already has openSUSE on his Raspberry? Do you have open? Oh, no. Who of you has openSUSE on his Raspberry already? You have, or who wants to have it on his Raspberry? Not yet. Nobody want? Oh, you want to? Okay. I don't know.
What's the real? It's the hardware inside.
Yeah, it's a board. The Raspberry is a screen board.
Is that? Sorry?
The Raspberry is a green board inside, and
Yes. And what is wrong?
you can order it on the internet. Just Google for buy Raspberry Pi, and there are some sources. Meanwhile, they make in the beginning they were very rare. You had to wait a month or 2 months to get one, but now it's better.
So how much did you say it was 40?
30 something, 40. Maybe you need a power supply here, USB power supply, and that's another €5. And you need an SD card, so it's a bit more, but not very much. Yeah, and the power supply never breaks.
And like packages.
Yeah, I did not make it, but it looks like laser cut. Wait a second.
Hallo. Testing. Test, test.
Test. Yeah. Test. Okay. We got a great microphone with feedback loops. So, okay. Okay, I got only one serial dongle. Dichter sein?
Ja, weiter weg.
Nee.
Du kannst es auch sonst, wenn du was sagen willst, dann nimmst du es einfach.
Okay. Ja. So, I only got one serial dongle. I got one serial dongle which is over there for now, but I guess you can set up SSH for your board then.
Yes.
Yes, good. You need power anyway. Yeah, but the power plug is full. Yeah, there's one monitor cable. Two.
Okay.
Yeah, but maybe you don't need it. Yeah, or just here. No, it's not Tom. Jesus. No, Jesus. It's an image. Yes.
This command.
No, not weird. Just OS.
This.
The pipe is the input.
Okay.
Yeah.
Because
Yeah, but it's in
Pipe-
gzip format,
pipe-
so you want just zkit.
HDB.
Yeah. Okay. OS. Yeah.
There's HDB.
Yes. Okay, try it. Yeah. It's not exit format. This is. Yeah. So the VD page is a bit wrong. Okay. So is your power cable long enough to get there? Okay.
Direct console.
So I'm going to class limits
Yeah.
first, then switch back to
Okay.
Ubuntu, and I guess that would be easy from there.
Yeah.
The Chinese thing you were talking about yesterday.
Which one? It's this one here, yes.
Yes.
Yeah. This is the working one and the broken one is over there. And it's,
Yes. You bought two.
yeah, I bought two of these Chinese serial dongles and one would not work.
One is working, the other one is not. It's 50% success.
Yeah, for €1.90.
It's better than 0%. So
Yes. I hope you write to the right disk. Okay. Okay. Huh? Yeah. Okay. Very good. What did you get?
I'm just dumping it in VSD.
Okay. Good.
What is it? Factory image. What was it?
Just do the image right there. You have
Or-
to download.
Oh no. I
What
think
is that
that's
used for?
maybe for Windows. Not sure.
It actually says you just dump the image.
Yeah.
So
That's the easy way.
yeah.
I always do DD on Linux at least.
Yeah.
I'm not sure about Mac.
Oh, it's DD still.
Yeah, but not divsd something on Mac. It's the disk device is a different one.
It's the same thing. It's no difference.
Yeah, DD yes, but dev here this dev sd is another device name, I guess.
It doesn't diff anything. It just says DD the.
Yeah, the image, but to where?
Oh yeah, it's /div /disk1.
Yeah.
Instead of.
Yeah, that's the one that.
What is sync right there?
Sync means make sure that all the data is written out. Yeah, like if you have to turn your machine hard off, then you want to do a sync before to make sure that all the data is on the file system. If it can be, but yeah, shutdown is even better. What's it?
Any idea how we can actually connect to the Raspberry Pi afterwards?
Yeah, we have some Ethernet cables. Maybe I get even more Ethernet cables, and then you do have Ethernet on here?
Yeah.
Okay. Yeah, so we just need to make sure about the IP configuration.
Does it have an IP set statically or
No, DHCP.
so set up a DHCP here?
You could, or we configure some static IP, then it's not too hard.
You should be able to just edit the ifconfig file.
Yeah, you can even edit it here while it's on the SD card. It's easy. Yeah. Okay. So, any questions so far? No? Not much to see, right?
No yet questions.
Yeah. Okay. So, over there, is something working already on the monitor? Yes.
So he already flashed the.
Yeah. You had it before. Yeah, maybe I fetch the... No, I could fetch the serial console dongle, and then we could just use serial. Yeah, console. Like, oh. Oops. Sorry? Can we borrow the serial dongle for a minute?
Yeah, I just rebooted. I installed some.
Okay. Oh. Okay. Now it gets interesting. Yeah, just wait some minutes. No, that's just for seeing what happens. It's a console, serial console, with a receive line, a transmit line, and a ground line. And the flashing, you have this SD card, and you can put the SD card in your computer, or SD card reader.
You flash it directly from your computer
Yeah.
and after you put it in.
Yes, that's the idea. And if you break it, you just take out the SD card and you can reflash it, or modify it so that it works again. Yeah, now reboot that. Let's see if it works. It's boot. Ah, that's for keyboard. Yeah, try the keyboard. Yeah, then you don't need the serial. Yeah. Yeah, there you are. Now you can set up IP networking. Maybe. Oh, it's an IP. Ah, 99.38. It has an automatic IP.
So that, but it shouldn't
Yeah.
have any IPs because there's
No.
no Ethernet, no Wi-Fi.
Yeah, but that's a fallback IP.
Yeah, but we don't have it plugged in. The cable. Yeah, I mean that
Okay, so it seems the Raspberry Pi gets an automatic IP address if it does not get a DHCP response, which is
192, 168?
yes, 99.38, which is what I had in my home network, so it kept it when I made the image.
99?
99. Yeah. Okay. And then you just power it up with the image. Okay. Take some time. Okay. I hope you guys are not too bored.
No.
Okay.
I have a couple of them.
At home. Oh.
At home, yeah.
Yeah.
I couldn't bring them because I come from away.
From?
100 kilometers away.
Ah.
I came with a car, so I couldn't come.
And you did not know before?
I didn't know there was going to be a workshop.
Ah.
There
Too
was
bad.
going to be a speech on how openSUSE integrates.
No. It's pretty much a side project of mine. So
So is the port in the works or is it working?
it's mostly working. And currently we are rebuilding everything for ARMv6, which is the actual Raspberry platform, but the image I had for now is ARMv5. It's a bit older, it runs on more different systems too, and also on Raspberry. Yeah.
I look forward to moving away from Raspberry.
Yeah. There are many alternatives, and openSUSE is not too bad. Yeah, of course, for us, for openSUSE, ARM is still a pretty new platform, so there can be problems, but
Isn't it always like that with innovation? Isn't it always like that when you innovate?
yeah, the new stuff is always.
And you've seen how some people have done it, so you want to do it better. Not only in some other way.
Yeah, it's evolutionary. Like you start small and then you grow. Yeah. Okay. Yeah. So, yeah, I think. I think we can borrow the serial console from you.
I can't seem to work with the console.
Yeah, let's steal it.
It's visible, but
You have your monitor. So
should the forward cable be...
yeah, it's not needed.
No, okay, so you want it.
Yeah, we need it for this one. Okay, and back there. And okay, let's see. Yeah, maybe no. Let's first start the serial console so that we see what is happening. Okay. Yeah. So stop. See what it's doing. Oops. What? From bitrate. No. Somehow it switches bitrate. It's not good. No. Just.
You booted?
Yeah, it booted, but somehow the serial console broke.
Okay.
No, let's just try the network. Here. Oops. Made the cable yourself?
Yes.
Yeah, I've done it.
Sorry, Mike, this is Bob.
Yeah, so let's try network, and we need an address. Address 192.168.9.24. Ah, no, different. So we have network connection to the Raspberry. Yeah, should be possible. Yes.
Maybe.
No. Let it run. It takes some time because there's no reverse DNS lookup. Yeah, include it. It's okay. But just wait half a minute. It needs to time out the DNS. It wants to know who's connecting and write it into its log file. So it will take a bit.
Yeah, so I use a server as a server.
As home server?
NAS box.
Yeah, then maybe you want SATA. Or do you have
external hard disk with a power cable on it.
Yeah.
Hard disk with power cable.
Yeah.
Because
it's not reacting. That's strange. Ping. Try the ping again. Oh, network is down somehow. Oh, and something happened. I think it was dark for a second. So maybe. Oh, there's a serial again. Ah, here we have something. It's not over SSH now, but direct over the serial line. And I have config.
Yes, it's not.
No, but you could, if you have internet,
What did it?
check the network. That's the network. But ETH2. Oops. No, ETH2. Yeah, but there's no network. It's offline. Yeah, you could configure it to send your network over your machine to the wireless, but it's a bit difficult. No, bridge does not work over wireless, not well, normally. Yeah, maybe, yeah, you can do it.
Okay, okay.
You do echo 1 to proxys IPv4. No, proxys net IPv4 IP forward. So forwarding and IP tables. Insert pre-routing source 192.168.99.0 something. Output on 0. Target masquerade. Not table. Not. And rerouting. So minus O is bad. Yeah, just so. The message. No, where is it? We don't have an IP. Why don't we have an IP? I think you have network manager running, maybe. Still not good. Okay, maybe no network for now. Oops. Maybe it's in post-routing.
Now you are routing the network via USB.
Yeah. No, over Ethernet. Over Ethernet through wireless. Okay. So now we need the default gateway. Yeah. Which one? Ethernet. Maybe ask up there or ask the organization. They have some.
What happens now?
You need a different address, and then it's automatically the default gateway. And now we can do ping to the internet. No ping.
No ping.
No.
No ping. Oh my god.
URL to the rescue.
let's ping this IP. And something's not working, so maybe traceroot. We have traceroot, haha. And traceroot minus n, maybe. So this one is reached, but something. H0. Oh, no. Does it not work? I think the IP table 2 is still wrong. Oops. What's that?
Έχεις βάλει και πλαίσιο.
Ούτε μέσα δεν τάσχω.
Όχι, το κάτω το...
Έβλεπα αρχιτεκτονικές ιστορίες.
That's good.
Δεν περιμένεις στο πανεπιστήμιο εργάζεσαι τα μάθημα.
Όχι ρε, εντάξει, περίμενα. Η περιγραφή του μαθήματος σου λέω μισή
Στο μάθημα σου πούνε ότι σου φτιάξουν και την Google ολόκληρη.
Ναι,
Μηχανή αναζήτηση με εκείνο που λέγεται.
σχεδιάζω έναν οχτάβο ξελαστή, ξαφνικά βλέπεις ξέρω ότι είναι 4 εντολές. Μην μας κορυφεύει.
Computer sensor.
Okay, ping does not go through. Ah, you have the SUSE firewall, I guess. Yeah. Okay. Then we need to allow it. IP tables, insert, forward. Just accept. Now. It's rejecting.
Το λαμπιώνει εκεί πέρα τι σημαίνει. Πάνω στο πλακετάκι. Όχι αυτό στο Raspberry, στο άλλο.
Yeah, so it's a bit tricky. Here. I think you have network manager and it dropped our IP again. So that's a bit ugly. So we put the IP on it and again. Now we have a balance. Now we just need a resolve con. Resolve con. Nano. Yeah, there's nano. And server, and that's wrong. And yeah, we use the Google name server at 8.8.8. Right, yes. And now we can do ref. Yes, trust that. Okay, something's working. We can forward Ethernet over wireless. Okay, so can you tell your network manager that it should not kill the network every minute? Not sure.
Okay.
I got an idea. Wire true, no, wire sleep 1, 2. So we just keep it up in spite of network manager. And we do it in the background like this. Ha! Just overwrite. So, yes. Yeah, I have a special repo for the kernel. because we had different kernel versions for the Raspberry Pi. Here.
Yes. On SUSE, on Debian.
No. No, there was a Linux 3.3 kernel for a long time, or 3.2. Okay, refreshed, and then we can do super install. What do we want? Ping we want.
Ping.
VI we want, and maybe just to network like this. Okay, no ping found, but the others. Okay, so looks good. Okay, and then you can use SSH, and we can reuse serial dongle if we need to, right? Or maybe try SSH. Try SSH to the .38 address.
Raspberry.
38. The one is your own address. No. .38. Yes.
I'm ready if you want.
Ah, good.
But I don't have any USB cable.
Okay.
I have one Ethernet cable.
Yes, that's good. That should be enough. Yeah. Okay. Oh, that's long. Yeah. I don't know. Just. Okay.
This is Debian Linux. I'm sorry, I couldn't make it to.
The Linux programs work everywhere. We just need a root shell, and then we can configure the Ethernet or sudo.
Configuration failure. Why?
No, maybe it's Ubuntu and you need sudo.
Sudo su.
No, minus s. So then you type in your own password because there is no root password. Yeah.
Okay.
And then we can use ifconfig on ETH0 and configure 192.168.99.1/24, and then we can ping this one.
I learned about the conference yesterday, and I couldn't make it to install openSUSE in my laptop.
Okay, so here you can ping your Raspberry.
Okay, and can we have SSH now?
Yeah, sure. But let's start a screen maybe before. Screen not installed, so up. No up.
Would you like to?
Screen.
May I have config? Όχι, IP για εδώ. Δεν έχουμε συνδυασμένη.
Yeah, you can get one cable to play with GPIOs like this. But make sure which one to use.
Need to have internet on the Raspberry Pi.
Only if you want to install extra packages, but for the basics you don't need to. You just do echo 2 procs, so something, and No SSH 192.168
And we have a user
dot
status.
68.99.38. Maybe root add. Then it takes some time because it cannot resolve the name.
99.38 is Raspberry's
Yeah,
address?
it's the default address for some reason. And
You have placed in /etc/network.conf this static address?
no, it's in the
In the distribution?
lost the address again. Or maybe we lost. ETH0. Yeah, we lost the address again. You have Network Manager running, and Network Manager thinks that you should not have an address here. So we put it on again. And now we get a connection. And here while sleep 1 to bracket. Yeah, so we keep the interface up, and Network Manager tries to take it down. But
our interface or
this one here.
This one. And why our Network Manager does that?
Not sure. It's maybe configured to know
it
that.
Is a Debian problem or generally?
In general, it did it on the other two. So now we have a connection to the Raspberry Pi.
And how we install the basic packages, like YAST and things like that?
Yeah,
like
for that you need internet connection with DNS. Yeah, right.
It doesn't have VI. Very sad here.
So nano again, and here we use again the Google name server.
This is the DNS, the Google DNS server.
And then we need internet forwarding. Do we have IP tables? Okay, that's good. And then we need in that post routing in the NAP table everything that comes from the 99 addresses should be masqueraded. And now network forwarding, proxies, net IP forward, and now we have internet.
Oh, thank you.
Okay, and with Super we can install.
Zyper is like aptitude.
Yes. I think we even have aptitude, which is.
Okay, but I would like to show me up the Zyper.
Yeah, actually,
user bin app.
this is just a wrapper script from me, and I made it to code Super with the right options. So if you know aptitude install Vim, it will call Super with the right Super install Vim. And
so aptitude script calls Zyper?
Yeah.
Oh, excellent. And that's your script?
Yeah.
Oh.
It's very short.
Congratulations.
Very short, very simple. And for example, if you say reinstall, it will map it to the Super options.
So you forward every aptitude command to Zyper?
Yeah.
Oh, that's great.
And it's very good for compatibility between distributions because people know how to use aptitude and not how to use Super. So I made this wrapper, and that's better for people.
I'd like to learn SUSE because in my work we all work members are using Debian, but I'd like to learn SUSE.
Yeah, Debian is also good. I have it on some of my servers.
Φτιάχνουμε e-government συστήματα με τα υπουργεία.
Okay. So now you can install packages.
The other USB cable that you have brought.
Yeah, that's for serial console.
And what does it do?
Yeah, you can reconfigure your network, for example.
Oh.
If you mess up your network, you can't access it anymore.
Oh.
Yeah, thank you. Yeah, and it's like...
Instead of unmounting the SD card and edit it manually, you use your...
Yeah, you can use this for your live system. It's just a serial console, like with your big computer where you can use a null modem cable to connect two computers with each other, and you can get kernel logs if it crashes. Like if you do kernel programming and it does a crash, it prints out where it crashed on the serial console. Oh. And you can copy and paste even from this output then, because it arrives on the other computer and the other computer is still working. So it's very good for debugging such a serial console.
Oh, that's good.
Yeah. And if you check the kernel, it's a 3.6 kernel, which I packaged. Yeah, sure.
3.6 kernel.
Yeah, and I packaged it for openSUSE.
And all the packages, the majority of the packages for the desktop run successfully in Raspberry.
Yeah, you can even have X11 with XFCE running on it.
Oh. And this openSUSE image for Raspberry comes with a window manager like Raspbian that has LXDE?
No, it's minimal image, just the shell.
Just the shell.
But you can install it.
Oh.
Say super install XFCE and then it will pull in most of it, but it takes a long time.
Okay.
Because SD card is slow and
for
internet is slow. Yeah, but you can. Yeah. It has very, very long list of packages, like 5,000, 6,000.
It can it can take quite large space in SD card.
Yeah.
For so many packages.
For Raspberry Pi, you can use only the command window, or you can install a desktop and have graphics in it. You can make some small PCs.
Yeah, you can, but it's not as easy yet, because I have not prepared it fully for this.
Oh.
Τι ρώτησες?
Αν ας πούμε, εκτός από μόνο αυτό το κομμάτι, μπορείς να βάλεις ένα desktop να έχεις γραφικά, να δώσεις και χρησιμοποιήσεις
Αυτό...
κάτι απλοϊκό, δηλαδή, όχι κάτι...
Το συγκεκριμένο είναι μόνο command line. Αν θέλεις να έχεις και να το συνδέσεις σε οθόνη, βάζεις κάποια άλλη διανομή ή φορτώνεις window manager, ουσιαστικά αυτό που βλέπεις μπροστά σου. Αλλά πρέπει να το φορτώσεις με εντολές, αυτό τον ρωτούσα τώρα. Και είναι αρκετή διαδικασία. Αλλιώς πρέπει να αλλάξεις άλλη διανομή που τα έχει από αυτόματα.
Θα ανεβάζεις βοήθεια
να γενικά αυτό δεν είναι... I say to our colleague that this computer is not for desktop usage.
Oh, you can.
You can, but
if you want to.
Yeah.
Because you have graphics and you can put it on your... Oh.
No, he loaded XBMC.
Interesting.
Guys, this is XBMC. Oh, that's good. And
yeah, so that's a nice thing with open source, because you can just recompile it for the other platform and have it there.
Oh, may I ask you something else? I have seen in the Raspberry Foundation that they have wiring Pi libraries for accessing GPIO and things like that. The wiring Pi library is installed here by default?
I have not done it. So it's not part of the normal firmware?
I mean that what library do you use in order to access GPIO ports?
No library.
Do you
No.
open the C file and you import
From
files?
I wrote a blog post about it here. Raspberry firmware. And I have this package, and that just has the bootloader stuff. It's a firmware package, nothing else. So now if you want the GPIOs, they are under this class GPIO. CD in here, and then you say I want to use GPIO number 18, and then you have here your GPIO 18, and then you say you want to use it as an output.
You redirect.
You can set the direction. The default is input because it's safe, and then you say okay, now it's an output, and then you can say the value is 1 and GPIO 18 value, and now it's on. It says power on pin.
Now it sends constantly power on.
On GPIO 18, and then you can turn it off again.
Go 0.
Yeah.
So you write a basic bash script, and you.
That's what I use for my traffic light adapter.
Oh, can I see that? Do you?
Yeah.
Do you have it running?
Yes.
What was the LED calculator for? And you have you redirect keyboard keys to GPIO commands.
Yeah, I have a script that says read, and then I get a variable with a character that was typed, and then
you have a combination.
No, just R for red and Y for yellow and G for green. That's a stripe board. Very simple design. And here in the middle I have cut it so that this side has different signals than this side. Do you see this cut here in between? Because it's a two-pin, double pin connector. And one side of the pins goes here and is connected here, and the other side of the pins is connected there.
So you cut it to...
Yeah.
And these are the old SATA and ID.
Yeah, it's a flat cable. It's a standard cable which you can get in all electronics markets, including these connectors. I made it myself with plugging these connectors into the cable. Yeah, so you can make the size you want. Of course, you don't want to make it too long because there's a current. Yeah, there's current going over here, and there's some resistance in the cable.
Or if you have problems with this, you can make twisted cables. What I use is this one. If I have a signal 1 GHz, I make twisted pairs. And this way, ground and signal, you can save, and you can have a safe and clear signal.
Yeah, but there's still resistance. So when you have a long cable, there will be some power lost.
I mean cables like this.
Yeah, that's okay.
So for this length, the resistance is like 0.
Yeah, really. That's okay.
And this is the USB to serial
Yeah,
transformer?
I bought it from China, but only one of two worked. And this one is a broken one. So if you want to have it, maybe you find the bug.
We can buy these.
I found it on eBay for €1.90, including shipping. And
you mean
so serial dongle. Yeah. So if you have some serial Do you need the keyboard? Or do you need... Okay, then... Yes. Okay, thank you.
Έχει ρελεδάκι, ρε παιδί, το παίρνεις στους ίδιους κατευθείαν με GPIO και θες.
Ah, okay, so here I type R and enter, and then my script sees, it's a letter R, so we do put this one out, so echo 0, echo 1, and then Y and...
You made 3 echoes at a time. For this combination, you emit 3 echoes.
Yeah.
2 zeros, 1.
Yeah, like this. Because I don't want the other to remain on.
Only one remains on.
Yeah, one of 3. So it should be a traffic light. So you don't want to be green and red at the same time.
Here in Greece, you may see that.
Oh,
you're kind of crazy.
I've seen some with no light on, which is like this.
Yes, it's quite common in weekends.
And of course, I can do this with all on. It's just another pass in my script when I say A, like all, and then yellow again. Yes, yes, it's a simple bash script. We can maybe even connect there and see it. This is done. You don't have HDMI or DVI?
You don't have an HDMI screen display.
Yeah, but DVI is easier normally. So stop the script. And yeah, it's not very good aligned. And maybe it crashed. I think it crashed. Then we reboot.
It's quite a silly question. If we say power off from the shell, is it really powering off, or we have to unplug the USB cable?
It's shutting down and some LEDs go out, so I'm not sure.
So we have to,
Yeah, you could use some power measurement to know it. So, yeah, not sure if it even can. It doesn't have a BIOS that tells it how to do it. Normally on PCs, the BIOS does the power off. So Linux just says, BIOS, please power off. And
here we don't have that.
what is this keyboard? Somehow. That's a problem. No. Hmm? Not. There's some. Now it's working. Okay. So something is. Okay. So this is a script, very simple one, fits on one screen. So it says here, this is a setup with the export of the GPIO and output direction. And then I have here the loop, the main loop, where it does a read one line. Here, while read. And then it does, basically a case. with many ifs. Where it says, if it's R, then do 0, 0, 1. If it's green, then do 1, 0, 0, like this. Yeah, so very simple, and you could write it in Python or in Bash, but if you can write it in Bash, it's the simple most thing you get. Yeah. So, we did not do yet the radio transmission. Did you have the radio transceiver? Receiver? No? Okay. Oh, just radio? No radio. Too bad. Okay. Then we don't do it.
I have found in eBay, from China of course, a circuit that has 8 relays that accept up to 250 volts, and I want to connect it with the GPIO and switch on large lights, and my father wants it, and he told me, make it.
Yeah, sure.
And I told him, okay, I'll try to.
Yeah, just make such a board with 8 GPIOs, and or maybe connect it directly with some cable.
I think that this circuit you can connect it directly with the GPIO, and you make just a script and it opens and closes the relays.
About the mean that the other device have a GPIO?
It is a board that has 8 relays.
But here,
it says that
So, does it work?
Yeah, confirms GPIO
Is working? Okay, and now send a 1. And then unplug the cable, and then you can see it changing.
I've already done it, but let me show it to you as well.
Yeah, so, no, but if you leave it on 1, you can have it as a switch. Like if the cable is there, then you get a 1, and if not, then not. So you could build an alarm system, for example. Yeah, so it's a switch now.
This seems to be a rather
Okay. Okay. So what is this?
Very good.
Very good.
I don't know.
No? What is very good?
It's an operating system that you can exactly a mini operating system that you can add any OS you want, and it has a bootloader when it starts.
What
It asks
bootloader?
you what do you want to put.
Okay, what bootloader do you have? Special?
I don't know.
Okay.
I don't know.
Yeah, because normally you don't have an interactive bootloader on Raspberry,
Yes.
but I guess they made one.
And now I'm installing the Raspberry.
So Raspberry.
Huh? The default Debian distro for Raspberry.
Ah, yeah. Okay.
Raspberry.
So. No. That's, yeah. Yeah.
Πρέπει να στείλεις ένα. Θέλεις A2D.
Όχι στα GPIOs, σαν κάποια που να γίνουν
Yeah.
A2D.
So,
Υπάρχει A2D port για αυτό το πράγμα. Το βάζει από πάνω και ουσιαστικά παίρνει το άναλογο. Άλλο αυτό. Είναι πρόσθετο, ναι.
We're talking about the analog and digital signal sending from the GPIOs.
yeah, mostly it's digital. Most of the time it is a digital signal.
These GPIO ports.
Yeah.
But GPIO ports 17 and 18 are it's a switch, right? If I set it as 0 or 1, I switch on or switch off the.
Yeah, it's digital.
Yeah. But remember, this is just a digital signal. It's not a power source or anything.
No,
Right?
it's very, very low, only a few milliwatt.
It's just for signaling. not for-
Milliampere. Yeah, but you can switch relays.
Yeah, or LED.
Yeah.
You use it practically as a controller and switch on off
Yeah.
external relays or anything.
That's exactly the reason for it,
Yeah.
to control relays and stuff.
Yeah.
So you don't power or using these ports. You just send the signals to enable all the
So instead of a button in ATX case, of a computing case, you can you can connect these cables to the motherboard. And you can switch on or you switch off your computer box.
Yeah, possibly. Yeah.
Well,
Sure.
the power button on a PC does just that. It short circuits 2 pins.
Yeah, so maybe you need a relay, because with this you only can send power or not send power, but some mainboards want you to connect 2 pins. And you can have a relay there to connect or not connect, and switch the relay with this cable.
To monitor the input. If you see one, that means that somebody closed the circuit. So now it's 0. So the switch is off.
Yeah, and in principle you could do a data transmission. Like one side sends 1010, and the other side receives, and you can even get feedback like, yes, I received your 1, yes, I received your 0. No, but it could be pretty fast in the end, even.
But if you receive 111,
You can't receive. No.
Yeah, you can have a clock, you have a pin that has to go up, or the other side has to toggle something before you continue, because otherwise you don't know if the other side has seen what you sent.
I see.
But yeah, you send a 1, the other side toggles to 0, you send another 1, the other side toggles to 1, but then maybe you need something else for timing.
There are multiple programs on how to do one value.
Yeah? Yeah, but you can do protocols. Yes, there are one-wire temperature sensors. And I know one guy, Lars, who did the IT here for the Congress, he made some temperature sensors for his Raspberry Pi for the SUSE server room to measure how hot it is.
We were talking about that yesterday, monitoring workshop.
Ah, good.
Because I had the idea that, well, if I can run Kinga or Nagios on this thing, I can use this just to monitor a couple of machines in there.
You sure? Sure. It's a computer.
But not to monitor 100 servers or 100 machines. But if you have this on a customer's remote site, and you can have it there running Kinga, just to have a look at 5 or 6 PCs or sensors or whatever, then this does the trick. And the good thing is that if or should this malfunction or get run over by a car or whatever, you can just ship another one to a customer with a pre-installed SD card, and he just has to plug it in, nothing else. No moving parts, no PC, no configuration, no nothing.
Yeah, no fans that can die.
Before you send it, you just make a copy of the content of the SD card, have it as a backup, and if it goes away or crashes or gets stolen or whatever, for €50 you can send it again.
Yeah, it's very cheap. Yeah. Yeah, and the nice thing is also that the part that die most is the hard disk of a computer and the fans and maybe the power supply, because there are some electrolytes.
But these power supplies are usually
no, it's lent from someone.
It is wooden or paper?
Wood. Laser cut wood.
Classic.
Can I open it?
I think it's glued or very tight at least. But I think there's just a Raspberry in it. And you see how it's built. Yeah. I guess someone has a 3D printer with a laser, and the internet has everything.
It's interesting how they have managed to make such big industry of Raspberry.
Yeah, because there are 1 million Raspberries in the world.
There are hundreds of brilliant ideas out there.
That's a very nice platform.
Yes, but it's very impressive how they promote all these things.
Yeah. And it's nice material. Yeah. Okay. Yeah. So I think we are pretty much done with the workshop for today. So thanks for coming.